All right, guys, today we're going to start our next unit. In our next unit, we're going to be working with some inequalities. Now, I know when you guys had me, whether it was first trimester or second trimester, we did do some solving of inequalities, and we graphed on the number line, things like that. I want to review some of that today with you to then hopefully connect it to our new idea with what we're going to be working with in this new unit. So hopefully we can take something old that we're very familiar with. A lot of you I know worked with inequalities last year too, and we worked with them last trimester also. So hopefully take something that we're already familiar with and make our new piece a little bit easier today. Okay? So the first thing I want to start with, if you look up at the top, the question asks you, 3 is a solution to which of the following inequalities? Remember, to be a solution, it needs to make an inequality true. So our task in those first 4 problems is to see if we put 3 in for x, will it make the inequality true? So let's take a look at number 1 together. If I replace x with 3, whoops, hang on, there we go. If I replace x with 3, that's all I did. Is that now a true statement? Is 3 greater than 2?
Yeah, why do 3 though? Any number is bigger, you just pick it.
We're just looking specifically at 3. That's all we're looking for right now. We're just looking specifically at 3. So is 3 bigger than 2? That is true. So 3 is a solution. I want to make sure we're kind of touching base on this idea of checking. I know we did a lot of checking last unit. We've done a lot of checking in many of our units, but I want to make sure we hit on that piece to start today. So it made my inequality true, so 3 is a solution. I want you to take a few minutes, try out the next 3, and see if 3 is a solution. Just stick with 3. I just randomly picked 3. So try it out. See if 3 is a solution to any of the other ones. I'm going to go ahead and put the next one up here just so you can make sure you're on the right track. Wherever I see x, I'm just going to replace it with a 3. I randomly chose 3. Don't get hung up on how did you get 3, Miss Golly. I randomly chose it. I could have picked. I could have put it wherever I want. We put 3 in for x. Just put 3 in for x. Then I do a little computation on that left side. 3 plus 4 is 7. And now I know for some of us you're thinking, Miss Golly, but I don't know those less than's, greater than's. I don't know how to read that. I've never been good at that. Well, then let's simplify it a little bit. Your symbol always opens towards the bigger number if the inequality is true. So is 7, that's a less than or equal to 6. Or if you need to look at it the other way, is my inequality opening towards the bigger number? No, it's not. It's opening towards the 6. I know for some of you, when you learn this, I'll draw my inequality a little bit bigger. Some of you learned, and I learned it this way, you learned the alligator eats the bigger number. And I had a teacher that drew a little alligator. It's not the greatest alligator in the world, but my teacher always told me the alligator eats the bigger number. So if I look at number 2, my alligator's not eating the bigger number. It's eating the 6, and 6 is a smaller number. So this one is false. That means 3 is not a solution. That's what that means. That's what that means. So that's all we're going to do for these first few questions is just see, is 3 a solution? Does it work? All right, so let's check it out. I know some of you are just doing some mental math and things on these, and that's okay as long as you've got it down. Wherever I see an x, I'm going to replace it with a 3. Just the x is going to change. Everything else is going to stay the same in that entire inequality. If you need to, take the right-hand side and you can put that in the calculator just as you see it. I don't want this to be a matter of we get these wrong because maybe we make a little mental math mistake here or there. I don't want that to happen for you. Use the technology if you need to. I know people kind of laugh if I call the calculator technology, but it is. It's been around a long time. If I do this piece by piece, 2 times 3 is 6. 6 minus 5 is 1. So as I look at those two values, if I read it just as is negative 5 less than 1? If you're not very good with, is that a less than, greater than, not sure how to read it, think about our gator. The gator's eating the 1. Looks more like a monster than a gator. Looks more like a monster than a gator, but our gator's eating the 1. The 1 is bigger than negative 5. This is true. 3 is a solution. Now in number 4, I wanted to make sure we did one, we got a little bit harder as we went here. In number 4, I do have an x on each side. That still doesn't change our process. Wherever I see an x, I'm going to replace it with a 3. Any place I see an x, it doesn't matter that there's an x on each side. Each x is going to become a 3. Then the x is out of there. No more x's. And again, if you need to, put each side in your calculator, parentheses and all. That's not a problem. Again, I'm not testing you on computation or any kind of mental math here. I'm checking to see, can you tell me if 3 is a solution? So again, if you want to work it out play by play, you can. We get 15 is greater than or equal to negative 2. 15 is greater than or equal to negative 2. Again, if you're not that great about reading what those inequality signs are, I can draw another little gator monster there. There we go. 15 is definitely bigger than negative 2. So my gator is going to eat the bigger number, and it sure is. This one is also true. 3 is a solution. So now notice, I didn't ask you to solve these. I didn't want you to try to get x by itself. I chose the number 3. Like I said before a couple times, it's totally random. I chose 3 to see if it made my inequalities true. Okay, so that's kind of the checking piece. That's going to be a big piece for us and where we're going next with this unit. The other piece that's going to help us, besides the checking, is the graphing on a number line. When I go to graph my inequalities on a number line, the first thing I need to decide is, am I going to do an open circle or a closed circle? Does anybody remember? We worked with inequalities this year. I know you worked with them last year. Does anybody remember, how do I tell if it's open or closed? All right, so I heard closed circle means there's an equal to. So it could be a greater than or equal to, or a less than or equal to. Or, I know you guys really don't graph often if it's just an equal to, but if we just had an equal sign, that would be a closed circle too. If we had x equals 3, we would just put a closed circle on 3. All right, so if we knew a closed circle meant there's an equal sign, that means open is just the greater or just the less. When we have that equals to, that number can be a solution, so we want to include it. That's why we fill it in. We fill it in because if it's an equals to, our number can be that for the solution, whatever that number the circle is on. All right, then the second piece of this, I really want to focus on this today, and we just refreshed on it. We want to test a number to see if it's a solution. I know back when we did inequalities, I had a lot of you that would just guess. Miss Gal, I got a 50-50 shot. I'm just going to shade left. I think it should be left. I'm just going to shade that way. Or I think it should be shaded right. I want to take that guessing out of it. You guys all just showed me, I walked around, you guys just all showed me you could put a number in for x and figure out if it's true or false. We're going to use that piece to help us make sure our graphing is solid. So let's just take a look. Graphing on a number line, again, you guys all did it last year. We did it this year. So I kept them very simple. I don't want us to do any solving. I don't want to worry about getting x by itself. We're already there. We just want a graph. So in number 1, first question is open or closed? What do we think? Open. There's no equals, so we're going to be open. Now, when we go to make our number line, all I ask of you, the number the open circle is going to be on, put it in the middle. And then all I ask is one number on each side. One number to the left of it, that's smaller. And one number to the right, that's bigger. That's all I ask. I don't need 10, 15 numbers on a number line. All right, so we've got our open circle. Now we need to test a number. The simplest ones to test are going to be the ones that are on our number line. So what do you guys want to try? Do you think 2 is going to work, or do you think 4 is going to work? Want to try 2? Okay. I'm going to test the number 2. So just like we did in the first 4 problems, I'm going to replace the x with 2. Nothing else changes. So I'm going to put a 2. I still have my less than sign, and I still have 3. I still have my less than sign, I still have 3. Is 2 less than 3? What do we think? This is true. This is true. So we want to shade. We want to shade 2. We want to shade whichever side 2 is on, which is over here on the left. So I didn't have to guess. I know I've shaded the right way. I didn't do a 50-50 guess. I didn't think, oh, well, the symbol's pointing left, so let's shade left. Just be very careful. I want you guys to go ahead and try out these next 3. See what you think. If you're like, Miss Golly, I don't know what you mean by testing a number. I just guess. I'm guilty of that. I guess. Let me know so I can help you out, because guessing is not going to work where we're headed next for the shading piece. I'm going to go ahead and put number 2 up here. I know we're not finished with all 3, but I just want to make sure. Just want to make sure we're doing okay with the checking. So I have 2 up there. Check your graph with mine. Maybe you chose to test 2 instead of 4. It doesn't matter which one you test. Let me know what I can help you out with. The one thing I do want to make sure, as I've walked around, I've seen a few people, you've started 3. Please be careful on your number line. Please be careful on your number line. When you start talking negatives, this is not -4 over here. I don't just take the positives and turn them negative. When we're talking negatives, even though it looks like the number part is getting bigger, it's actually getting smaller. If we think about it, I'm just going to extend mine out. You don't have to. I'm going to extend mine out. 0 is over here to the right. And then we go negative. It's 1, 2, 3, 4. We keep moving to the left. So be very, very careful when you're numbering that negative number line. Those numbers are going to go in opposite order of the positives. Positives go 1, 2, 3, 4, going to the right. Negatives, -1, -2, -3, they go that way to the left. So just be careful on that. So then we make our comparison with the negatives. Again, we also have to stop and think. Negatives are literally opposites of the positive. +2 is not bigger than +3, but -2 is bigger than -3. This is a true. So we're going to shade the side with -2. The negatives are literally opposites of the positives. That's what they are. So just be careful when you're numbering your number line, those numbers are going to go the opposite order as the positives. When you're comparing them, it's opposite of what it would be if it's positive. Just be careful on the negatives. Last but not least, number 4, we have that equal to, so we're going to be closed again. Be careful when you're numbering that negative number line. So you have a closed circle on -3. And let's test out. It doesn't matter which one you test. I'll just show you. The 3 I've tested so far have all worked. If I would choose -2 to test, let's say, -3 is not greater than -2. It's not bigger than -2. My gator's still going to be hungry if it's eating -3. So this is actually false. Don't shade -2. So that means we're going to shade the side with -4. So if you choose a number, I know same thing Miss Golly, but I didn't pick -4 on this one. I picked -2. If it doesn't work, that's okay. That means you need the other side of that number. So if I pick -2 and it doesn't work, I want to shade the other side of -3. If you want to, you can always double check. If the first number you pick doesn't work, try a number on the other side. That's okay. If you picked -2 the first time, you're like, wait, that doesn't make sense, then try a different number. See if -4 works. This is true, so we do want to shade where -4 is. Now I know some of you are thinking, but Miss Golly, I can do those without testing a number. I like to shade the way the sign's pointing. That doesn't always work. Take a look at number 1. I have a less than in number 1, and I shaded left. I have a less than in number 2, but I shaded to the right. A greater than in number 3, I shaded right, but the same symbol in number 4, I shaded left. So it's not about which way the symbol is pointing, is which way I want to try to guess at my number line. It doesn't take long to pop a number in and check. That doesn't take us long at all to compare 3 and 4, or -2 and -3. It doesn't take long. And you can pick any number you want. Over here I picked one that didn't work, and that's okay. If I picked one that didn't work, I shade the other side. That's okay. So I know some of you think, Miss Golly, we've done all this year. I did all this last year. Yep, you're right. Because it's my goal that we refresh on something that we already know how to do, and hopefully it makes the new piece we're going to look at today a little easier. So let's go to the back side of our sheet, and let's look at the new idea. Or getting to the new idea, I should say. We're going to keep building with what we already know how to do. All right, so as we look at the back side, the first question says 2, 3. It's an ordered pair. Is a solution to which of the following? What's different about these first 4 versus how we started today? There's 2 variables. There's an x and a y. So that means just a number like 3 can't be a solution all by itself. We need that ordered pair. We need an x and a y. So we're going to do the same thing we did with the opening 4, except now we need to substitute in for x and y. So really similar to what we were doing last unit. We had ordered pairs that we had to check out last unit. So wherever I see an x, I'm going to put a 2. Wherever I see a y, I'm going to put a 3. The x's and y's are gone. I know for some of us last unit, that's where we got a little stuck. We'd substitute a 2 in for x, but we'd still put an x with it. Notice instead of x, I have a 2. I still have my plus sign, and then I have my 3 instead of my y. Still have the greater than, still have the 2. 2 plus 3 is 5. Is 5 greater than 2? Or is my symbol opening towards the bigger number? Yes. This is true. So 2, 3 is a solution. So what I want you to do is go ahead and try out numbers 2, 3, and 4. Use the same ordered pair, just use 2, 3. See if it works. I'm just going to slowly start putting these up here. Just going to slowly start putting these up here. Double check yours with mine as you go. So I walked around, most people had number 2 finished already, so I'm going to go ahead and put that up. Just be careful. When we substitute into this one, the 4 still stays there. I only get to put the 3 in for the y. So we do have to multiply 4 times 3. And again, don't get too hung up on, I just randomly picked 2, 3 as the ordered pair. I randomly picked it. I didn't solve anything. I just want us to test it and see if it works. That's all I'm going for. As you move on to number 3, be very careful. This tripped up some people in my first period class today. The y comes first in number 3. So we have to make sure it's -5 times 3 for the y. And then 2 times I put a 2 in for my x. So just be really careful. We can't always just put 2 in for the first variable because 2 is listed first in the ordered pair. So I get -15 is less than, I get 4 minus 5. Is -15 less than -1? Or in other words, is my sign opening towards the bigger number? Yes. Remember, negatives are literally the opposite of positives. Positive 15 is not less than positive 1, but negative 15 is less than -1. So this is true. That means 2, 3 is a solution. It's not the only solution. Last unit we just had one solution. If that ordered pair worked, that was our solution and we moved on. Alright, then last but not least in number 4, we put a 2 in for the x and we put a 3 in for our y. 8 plus 3 is 11 greater than or equal to 3. It sure is. 2, 3 is a solution. And this should be, I know we didn't do inequalities last unit, but the idea of substituting an ordered pair in for x and y, that should be familiar for us. So far today, we haven't done anything new. We've tested a value, we've tested an ordered pair, we've talked about open and closed circles, we've graphed on a number line. So far, nothing new. Our first new piece is coming at us right now. When we go to graph these linear inequalities, Chase pointed it out before to us, hey, these are different because they have 2 variables. So now that we have 2 variables, now when we graph, we need 2 dimensions. On the front side of this sheet, we only had 1 variable, so we just needed 1 dimension on that number line. We just got to draw that number line straight across and we shaded either the left or right side. Now with 2 variables, we need 2 dimensions. We need an x-axis and we need a y-axis. We need that coordinate plane that we've been graphing on all year. So now when we go to graph, instead of just having a number line, we have to graph an actual boundary line. So when we go to graph that boundary line, that concept of open or closed circle comes into play. But it's not going to be an open or closed line. It's going to be either a dotted or a solid line. So let's think about what we know about open and closed circles with our one-dimensional graphing. When do you think we're going to have a dotted line versus a solid line? What do we think? What do we think based on what we did with our open and closed circles? When we had open circles, we didn't have an equal to. When we had closed circles, we had an equal to or an equal sign. It's going to be the same idea. So its dotted line is going to be like an open circle. A dotted line is going to be our version of an open circle when we graph. So a dotted line is going to be when we just have a greater than or we just have a less than when there's no equal to. We can't just leave a boundary line wide open like we could an open circle. So a dotted line is the equivalent of our open circle. Our solid line is our equivalent of a closed circle. And the closed circle happened when we had equal to's. So I'm trying to, like I said, all that front review work we did, I'm trying to help you connect it to our new pieces. So our dotted line is like our open circle. Our solid line is like our closed circle. We use them at the same times. So if there's no equal sign, that's a dotted line. Same as we had an open circle. If there's an equal sign, an equal to, a greater than or equal to, less than or equal to, and an equal sign, that's like our closed circle. It's going to be our solid line when we graph. So this is right here, this is new idea number 1 for us. The idea of having a dotted or a solid line. We've graphed lines a ton this year already, but they've always been solid for us. We've always had equal signs. So this is new idea number 1. The next piece of this, though, is not a new idea for us. When we actually graph our line, we have 2 different forms we could use. We did a lot of graphing last unit, but I want to make sure I refresh on these forms today with you. Slope-intercept form is when we have y all by itself, when we have a y equals. Or in this case, it might be a greater than or a less than or any of those inequality symbols. The m is our slope. And remember, m for married. The slope is married to x. It's always with it. When you have your slope, remember, it's the up or down over the left or right, whichever it happens to be. See, up, down, over the left, right. It's your rise over your run. The B part of this is the Y-intercept. Now, I know everybody in this room can graph with slope-intercept form. If I tell you you have slope-intercept form, then you're able to pick out slope, Y-intercept, and you rock it from there. But we have to continue working like we did last unit, picking out when I have slope-intercept form all on my own. The second type we could have is standard form. That's when x and y are on the same side. X and y are on the same side. When that happens, we use x and y intercepts. And that's when I like to make the little T-chart. Some of you don't like to make it, but as soon as I draw it, that helps you remember, oh yeah, that's how I graph these. And I know every single one of you out there at some point in time could graph in standard form. But again, that's if I told you you have standard form. But now, just like last unit, we have to start being able to recognize on our own which of those forms I have. Which of those forms do I have to make my graphing life a little easier? Then last but not least, here comes our second new idea. We need to test an ordered pair. to see if it's a solution. So when we had our one-dimensional, single old, just horizontal number lines, we had the one dimension, I tested a number, and if that number made the inequality true, I shaded that number. I shaded that side. If it didn't work, I shaded the other side. It's the same idea now that we're working in 2 dimensions, except for instead of testing a single number, I have to test an ordered pair. If that ordered pair works, I want to shade that side of the line. If that ordered pair doesn't work, I want the other side. Okay? So those are the only 2 new ideas we have. We know how to test ordered pairs. We know how to graph lines. New idea number 1, my line might be dotted or solid. New idea number 2, we're going to have to test an ordered pair to shade on our actual coordinate plane, our 2-dimensional x and y coordinate plane. So not a lot new today. I know you're thinking, Miss Golly, we've done a lot of work and we have just those 2 new pieces. Yep, because hopefully that review work is going to help make this a little easier for us. That was my goal today. So let's put it all together. Let's do the new thing. Let's just do a couple of them today. We'll call it good for today. Let's do a couple today. All right, so let's take a look at number 1. We have some decisions to make here. First decision, am I going to draw a dotted line or a solid line when I graph this? What do we think? Dotted. There's no equal to. If you're like, oh, it's going to take some getting used to, Miss Golly, think about open and closed circles. You guys rocked at that when we solved inequalities last trimester. Think about it that way. If you're not sure dotted or solid, think of it as open or closed. Which would you have graphed? The next thing we need before we can even graph that line is we have to figure out what the heck form we have. I've got a y by itself, so which one do I have? Slope-intercept. Now with slope-intercept, I want to go ahead and I want to write this out. I know for some of you it really helps to write out the slope and the y-intercept. For others of you, you can just grab it right from the equation or inequality and go with it from there. So which one of those numbers would be my slope? What do we think? The 2/3, yeah. Now it's not my slope just because it's the fraction. It's my slope because it's with the x. It's the x coefficient. That's why it's my slope, not because it's the fraction. So I can move how for a slope of 2/3? I can go up 2 and write 3. Now we're going to be making, I know this is our first one of these, we're going to be making a boundary line. So we want to use this to cut our graph into 2 separate pieces. So instead of moving up and right, how else could I move if I want a few more points? Down and left. So we can go down 2, left 3. So again, that's my slope, not because it's a fraction, but because it's the x coefficient. Or in other words, the number that's stuck with the x. All right, then we have our y-intercept. Well, the only number we have left is -4. If it helps you to write it as the ordered pair 0, -4, like we did when we first started graphing this year, not a bad idea. It also might help, and I see a lot of you do this, if I don't label the axes for you, I see a lot of you that go ahead and throw those labels on there. That's a fantastic idea. I know of a couple of you out there that do that if I don't label them. Y-intercept goes on the y-axis, so I'm going to find -4 on the y. And then I'm going to follow my directions for my slope. Up 2, right 3. Up 2, right 3. And I'm going to go ahead and go down 2 and left 3 also, just to finish it off. Now I know, and this is a hard habit to break, guys, we've graphed a lot of lines this year. You probably graphed a lot of lines last year. You're used to just drawing a nice solid line. This is where you really have to slow yourself down and stop and remember, is it going to be dotted or solid? If it's dotted, or you can call it dashed if you want, Just literally draw little dashes. Don't do a completely filled in line. You can still put your straight edge there. Just draw little dashes as you go is all. That's just a dotted line. Or if you want to call it a dash line, I always debate which one to call it. I like dotted. They look more like dashes. It's up to you. Either way you like. So we have our line graphed. So far in this problem, only new idea is we had to have a dotted line because there wasn't an equals. Otherwise, how we graphed that line with slope-intercept form, how we found our y-intercept, how we graphed it, how we graphed our slope, that's nothing new. Okay, I know sometimes it can be overwhelming when it's like, oh, it's a new unit. We've done one new thing so far. Now we have to figure out which side to shade on. And just like the number lines, I don't want you to guess. I don't want you to guess. Oh, I think I'm going to shade on the top, or I think I'm going to shade on the bottom. That looks good. I don't want you to guess. We're going to test an ordered pair. And it has to be an ordered pair because I have an x and a y in my inequality. I have an x and a y. So we can pick any ordered pair we want except for any of them that are on my boundary line. Why can't I pick ordered pairs on my boundary line? Are they going to help me figure out if I'm going to shade up top or down below? No, they're not going to help me. If I pick a point on that boundary line and I test it, it's not going to help me decide if I should shade up here or down here because the point's on the line. That's not going to help me. So you can test any ordered pair you want as long as it's not on that boundary line. What do you guys think might be the easiest ordered pair in the whole wide world to test? 0, 0. Yeah. 0, 0. Here's where 0, 0 is. I'm just going to highlight it right there. Here's why 0, 0 is easy. First of all, can I goof up where it's at on the graph? No, it's right in the middle. It's the origin. 0, 0 smack in the middle. Can I screw up? Can I screw up which value goes in for x and which one goes in for y? No, because they're both zeros. And 0 is probably one of the easiest numbers to add, subtract, and multiply and divide with. Probably the easiest one. So here's how we test. Here's how we test. We have y is greater than 2/3 x minus 4. So in for the y, I'm going to put a 0. In for the x, I'm going to put a 0. So just like we started with those top 4 problems, I have an ordered pair. I want to test it out to see if it's a solution. So when I test it out, is 0 greater than, we have 0 minus 4, is 0 greater than negative 4? What do we think? Yeah, 0 is bigger than negative 4. This is true. So I want to shade. I want to shade where 0, 0 is. I want to shade where 0, 0 is. 0, 0 is on this top side of the line. I want to shade where 0, 0 is. And it doesn't have to be perfect shading. It doesn't have to be perfect. It just has to stay on that side of the line. That's all we're going for. So the only new idea, there's 2 of them. I shouldn't say the only one. New idea number 1, we had a dotted instead of a solid line. So that's something we have to watch for. Then the second new idea, I had to test an ordered pair, not just a number, to decide where to shade. But how to substitute that into test, that's not a new idea for us. The idea of shading on that graph is new, but how we can test isn't. Now I get some people, I like to show this. Some people really like it. Some people are like, I'm good just testing 1 point. Some people like to do, I call it a double check. Call it a double check. So after I shade, I pick another ordered pair in the shaded piece just to make sure I'm right. What would be another easy ordered pair to test in that purple shaded part? 1, 1, sure. Here's where 1, 1 is in the shaded part. and we want to shade solutions. We want to shade ordered pairs that are going to make our inequality true. And you can test out 1, 1. 1, 1's another great easy point. Easy to find on the graph. 1 is easy to multiply, add, subtract, multiply, divide with, all that good stuff. And I can't get the x and y backwards because they're the same. Now some of you, 1, 1, you might be thinking, Miss Golly, but that's going to be hard. I've got that fraction. Use the technology, guys. I've got the calculators in here. They have the fraction key. So if you're worried about the fractions, don't be. I'm not testing you on computation. I'm testing you to see if you know which side of the line to shade. What's going to make our inequality true? If I do my subtraction, I got negative 3 1/3. 1 is definitely bigger than that. So now I've tested not only 1, but now I've tested 2 points to make sure I got the right side of the line. Now I'm good to go. All right, let's just take a look at, got a little bit of time left. We're going to skip number 2 for today. I want to look at number 3. I want to look at number 3 today. So skip number 2 for me, please. I want to look at number 3. With number 3, we're going to have a dotted or solid line. What do you guys think? Solid. Yep, we've got an equal sign. So we're going to have a solid line in number 3. We have a solid line in number 3. Now, I know number 3 looks a little bit different. I know for most of you, like Miss Golly, I like my variables to be over on the left. When I learned to graph or anything else, I always had the variables on the left. Now this year you're mixing them up on me. I don't like it. You can put your variables over on the left if you need to. So if you want the negative 2x plus y over on the left and you want the 6 over on the right, that's okay. But you have to make sure that that inequality symbol gets flipped as well. My inequality symbol is opening towards the negative 2x plus y. So it has to stay opening towards the negative 2x plus y. So if you want to flip-flop the two sides, that's okay. If you want the variables on the left, that's fine. I get it. A lot of you have done a lot of practice that way. You have to flip the inequality as well. Okay? We've got x and y on the same side. So do we have slope-intercept or standard? We have standard, yeah. We have standard form, which means we want to use our intercepts to graph. And you can do this however you like. I noticed a lot of you like to put 0 in for x first. And you can use either you want. If you want the variables switched to the left, if you want to keep them on the right, it doesn't matter. I'm just going to keep them over on the right. We have 6. And when you do this part, when you go to find your intercepts, guys, keep it simple. You can just make that inequality an equal sign. We're just looking for intercepts. We don't care if something's less than or greater than. That doesn't matter. Make it a little easier for yourself. Make that an equal sign. Negative 2, I'm going to put a 0 in for x to start. Negative 2 times 0, it's just a 0. See you later. My y equals 6. Now I do the same thing, except for my y is a 0. My y is a 0, so that's out of there. Divide by negative 2. Negative 3 is my x. Now that's not my solution. I didn't solve anything. All I did was find intercepts. My y-intercept on the y-axis, we found y was 6. We found x was negative 3. So I didn't solve anything. I don't just stop here and say, okay, problem done, peace out, mic drop. All I have now is my boundary line. And we said it's a solid line, so I'm going to go ahead and draw that in. When you draw your boundary line, it needs to go all the way across your graph. We only need 2 points to make a line. We just need the x and y-intercepts. That's okay. We're not trying to see where 2 lines intersect. We just need one single boundary line. And we want it to cut our graph in half there. All right. Easiest point in the world to test? 0, 0. Easiest point, they don't get any easier. The only time you can't use it, though, is if our boundary line would happen to go through that point. Because if the boundary line goes through it, it's not going to help me figure out if I shade above or below that line. So you'd have to pick something else. All right, so we've got, don't remember if it's a greater than or less than. Sorry, guys. 6 is less than. I'm going to rewrite it down here. Mine doesn't fit all at once on the screen. All right, so here's what we have. We need to test it. Is 6 less than or equal to -2 times 0 plus 0? So is 6 less than or equal to 0 plus 0? Is 6 less than or equal to 0? What do we think? Is 6 less than or equal to 0? No. All right, so this is a false. So we don't shade 0, 0. We don't shade 0, 0. That means we need to shade the side that doesn't have 0, 0 on it. If 0, 0 doesn't make my inequality true, I don't get to shade it. And I hope all my people playing on phones right now are picking up on this. 0, 0 didn't work, guys. Didn't work. So now here's where the double check comes in handy. Because I know I have people, they get nervous when they try 0, 0 and it doesn't work. They're like, oh, do I really shade the other side? That's where the double check comes in. Let's take a look on that other side. And we want to find an ordered pair. There's a lot of negative stuff. We're not really going to get anything positive on this graph. So what do we want to do? Well, we can. Where do we want to go to? Let's go. We could go negative. We can go -3, 3, let's say. We're not always going to get an easy point to test. We're not always going to get a 0, 0 or a 1, 1 that works. I need to choose something that's in the shaded part. So I just picked -3, 3. You could have picked any ordered pair in that shaded part that you want to. We could go -4, 2, -2, 5. Any ordered pair in that shaded part. Now you might need to label x and y. We have 6 is less than or equal to -2 times my x, which is -3, plus y, which is 3. So 6 is less than or equal to 6 plus 3. 6 is less than or equal to 9. This is true, and that's what we need. I know some people are like, Miss Golly, oh, I don't want to have to test 2 separate points. That's how you're going to be able to make sure that you did shade the right side. You can put this computation stuff, guys. I know for some of these, it looks like I'm doing 1, 2, 3, 4, like 4 steps. You can pop stuff in the calculator if you want to. I'm showing every single possible step. Okay? So again, new ideas today. We might have a dotted line instead of a solid. Other new ideas, we have to actually shade on our graph. How to decide where to shade? Really similar to shading on the number line. We have to test an ordered pair though instead of just a single number. So that might make it a little bit more work because we have an x and a y versus just having an x there. Okay. So this is where we're just going to leave off for today. Tomorrow is going to be your day to practice this. Okay.